Hello, geometers. It's Ms. Backfish back to talk to you about triangle congruence. And you may have come here from my last video, which was also about triangle congruence. There are 5 triangle congruence postulates and theorems. The other video was about side, 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 and side, angle, side. This video, we're going to start talking instead about angle, angle, side, angle, and hypotenuse leg. Okay, so before we get into the nitty-gritty on that, let's just remember the whole big picture here. The whole idea here is that I am coming up with, or I am learning about, the reasons I'm allowed to say 2 triangles are congruent. If I know everything about the triangles, if I know all 3 angles on both triangles, all 3 sides on both triangles, then I don't need any extra reasons to say they're congruent. I can look and say, look, all the angles are the same, all the sides are the same. That's 6 things that are the same. Everything's congruent. These are my shortcuts, okay? What if I don't know all 6 things? Well, here are my 5 shortcuts. These are the triangle congruence postulates or theorems. I don't know if your teacher makes you be picky about which one's a postulate, which one's a theorem. I'm not picky about that, so that's between you and your teacher, let's put it that way. If they want you to name them specifically, then feel free to learn those names. But we just talked about side, 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 and side, angle, side, which are usually the postulates. And then we are going from there into talking about angle, side, angle, angle, side, and hypotenuse leg. So let's look at some of the most basic examples first. Okay, in general, if I want to look at angle, side, that's 2 pairs of angles, 1 pair of sides. Okay, so let's say this pair of angles is congruent, and maybe this pair of angles is congruent. Now, the thing that makes it different from angle, side, angle is where the side is, okay, or where the pair of congruent sides are. Notice here that the S is not in between the 2 A's. If the S was in between the 2 A's, the side would have to be in between the 2 angles. That's called the included side. This time the S is not in between, so this is not included. So it's not going to be the one in between the 2 angles. It could be this side over here, or it could also be this side over here. Either way, this would be angle, side. Okay, let's look at that in comparison to angle, side, angle. Angle, side, angle also has 2 pairs of angles that are congruent and 1 pair of sides. The difference is the S is between the 2 A's, and that means the side has to be between the 2 angles. We call it the included side for those 2 angles. And you might want to go check out my video on included sides and included angles if that's something you think you might need to learn more about. So the included side between 2 angles means I look at the 2 vertices of the angles. Okay, here's the vertex of one of my angles that's marked. Here's the vertex of the other one. If I trace the side that goes between them, that's the included side. Same goes here. Vertex, vertex, trace the line segment between them. That is my included side. That is the side that needs to be congruent for it to be angle, side, angle. Now the bigger picture is, what's cool about these 2 is if you know that you have 2 pairs of angles that are congruent and 1 pair of sides, then it's going to be one of these. So if you have 2 pairs of angles and 1 pair of sides that you know are congruent, the triangles are definitely congruent. All you have to do is decide which one of these it is. Either the side is the included side on both triangles, or the side is not the included side on both triangles. I just realized that what I'm saying is a little bit off. That's assuming the 2 triangles match. Now, if it was half of one and half of the other, that would be a no. Like maybe it was included on one triangle and not included on the other triangle, that'd be a problem. But as long as they're consistent and either both are the included side or both are not the included side, then you're going to have congruent triangles by either AAS or ASA. Okay, so let's look at a few of those first before we talk about hypotenuse leg. Okay, here we have 2 triangles, look a little like a bow tie, joined at point G. Triangle EFG is on the left and triangle GHJ is on the right. I'm told that EF is congruent to HJ, and that angle E is congruent to angle J. So that's all I know so far. So remember, if you need to be able to tell me whether the triangles are congruent, you have to know at least 3 things in terms of 3 congruences. I know 1 pair of sides and I know 1 pair of angles. That means either I can't do it, or maybe I need to go looking and see if there's something else that I actually do know, even though it's not marked. And in this case, that would be the vertical angles. Vertical angles are always congruent, so I can always say they're congruent even though they're not marked. So now I have 2 pairs of angles. Here's the first pair, and here's the second pair. And I've got a pair of sides. 2 pairs of angles, 1 pair of sides. That means chances are pretty good one of these is going to apply. Now I just have to figure out how the pair of sides relates to the angles in each triangle. Okay, so looking over here in triangle EFG, is this side the side between the 2 angles that are marked? That's a no. That would be this side right here. Okay, what about over here? Is this side the side between the 2 angles that are marked? Again, no. The included side would be right here. So over here, this side is not the included side. This side is not the included side. So the S is not in between the 2 A's. And we have AAS. These 2 triangles are congruent by AAS. And very often I would be asked to say it that way right there. Okay, what about this one? It's a little weird looking. Matter of fact, I don't see any congruence markings at all. There aren't any. What are all those arrows? Don't look at arrows and think they mean congruent, because they don't. This is not congruent to that I know of. Maybe it will be, but it's not been marked. And this is not a marking that tells me that ZW and YX are congruent. What it does tell me is that they're parallel. So remember, parallel lines, when they are crossed by a transversal, have all kinds of angle relationships, alternate exterior angles, alternate interior angles, things like that. A lot of times with triangles, what we're looking for with parallel lines is alternate interior angles. And for this pair of parallel lines, ZY and WX, I have alternate interior angles right here. Remember, alternate interior angles very often make sort of like a Z shape or N shape, and it can be like a backwards Z or backwards N. And when you have that Z shape, it's the inside corners of the Z that are your alternate interior angles. And it's only in a situation where alternate interior angles are congruent if the top and bottom of the Z, or you could think of it as the sides of the N, are parallel. And in this case, yes, they are. Okay, so ZY and WX make these angles congruent by being parallel. Then these other 2 sides, by being parallel, ZW, this is like my backwards N, or backwards Z. Actually, that is backwards Z. Okay, those 2 make this angle congruent to this angle by alternate interior angles theorem. So there's 2 pairs of angles that I know that are congruent. Let's mark them a little darker now. So congruent angle, congruent pair of angles. All right, now what's left? I've got 2 pairs of angles. Is that all? Do I know anything else? Yes, I know that any segment is congruent to itself. WY is congruent to itself. I have a shared side there. So I'm going to mark that that is congruent to itself. Remember, when they are linked like this, if you're having trouble seeing it, you can always draw them sort of pulled apart, like so. And sometimes that can make it a little bit clearer what's going on in terms of things that are congruent. So WY is in both triangles. And of course, WY is congruent to itself. Everything is congruent to itself by the reflexive property. So I'm going to say that is a pair of congruent sides. So now what do I have? Well, let's go ahead and look at it this way. I have 2 pairs of angles and 1 pair of sides. Is the side in every triangle, in both triangles, is it the included side? Well, here's a vertex, here's a vertex. Trace your way from one to the other. Yes, it is on that one. Here's the vertex, Here's the vertex. Trace your way from one to the other. Yes, this side, WY, is the included side in both triangles. So I can say that triangle WYZ is congruent to triangle YWX by angle-side-angle theorem. Remember that this is called a triangle congruent statement. That's important to know. Sometimes triangle congruency statement, but triangle congruent statement, triangle congruent statement, congruency statement. It's important to know because if you're asked to provide one, you need to know what you're being asked to provide. So that's what that is. Okay, so this is not my best drawing, but it's also not my worst, so I'm going with it. Okay, so let's suppose I have these two triangles, QRV and TSR, and I have this information, matching arrows, and I have this information. Let me remind you that sometimes you're given the exact same information I just marked without congruence markings or without being direct about it, a little bit more indirectly. And here's what I mean. If they say R is the midpoint of segment VS, that tells me by definition of midpoint that these two segments are congruent. So that's another way of giving me that same information. Okay, so let's suppose I have this info. This is a pretty interesting problem and it comes up a pretty good bit. So I've got I've only got one thing. Well, I have two things. I have parallel segments, but that's not a congruence. And then I have one pair of congruent segments. So I really only have one congruence right now to work with. So there's got to be more in this picture that I'm supposed to know, and it probably has to do with those parallel lines. It does. Parallel lines, remember, make alternate interior angles. They also make alternate exterior angles, alternate interior angles that are congruent, specifically alternate exterior angles that are congruent, corresponding angles that are congruent, same side interior angles that are supplementary. So in this case, if I can see if I have any alternate interior angles, which I do, they will automatically be congruent. Okay, so remember, alternate interior angles make kind of like a Z. Okay, so QT, because it connects those two parallel segments. Here are my parallel segments. QT is my transversal. Okay, so one pair of alternate interior angles is right here. Angle Q and angle T will be congruent because those are alternate interior angles. Okay, let me turn it where it's sort of, let's see if you can see it. Makes kind of like a Z. Alternate interior angles often make like a Z shape, and it's the inside corner. Could be a backward Z. You could think of it as like an N. It's like a slanty N. Okay. Now, the thing is, I also have another pair of alternate interior angles. My other pair of alternate interior angles is right here with this one. This time, VZ is the transversal. I'm sorry, I smudged you, Mr. Angle. VZ is a transversal connecting those two parallel lines, making this pair of alternate interior angles. Furthermore, this is still not all that I know about this triangle or these two triangles in terms of things that aren't marked. I also have a pair of vertical angles. So I've got all these angles. So could this be angle, angle, angle? No, because it doesn't exist. Now, when I say it doesn't exist, it does not exist as a congruence theorem. There is no angle, angle, angle congruence theorem. If I know that all the angles are the same, that does not make them congruent. An example, if you draw a triangle, think about it like an equilateral triangle. If I draw an equilateral triangle, I could draw a really small one, or I could draw a much bigger one. Those are definitely not congruent. But remember, in every equilateral triangle, all three angles are each 60 degrees. So just because all these angles match, because all of these are 60 degrees, does not make the triangles congruent. Those are clearly not congruent triangles. Okay? So no, there is no AAA for triangle congruence. So then what do we have? Well, we still have that pair of sides. Don't forget about them. So I can use those. This is why this is kind of a cool problem. I could say angle, side, angle, or I could also say angle, angle, side. I could do it either way. I could look at this pair of angles, and then these are the included sides. This side RS is included between the angles with a vertex at R and one at S. This side over here, VR, is included between these two angles. So that would be ASA. So I'm going to say QRV is congruent to Q goes with T, R goes with R, V and S, TRS by angle, side, angle. But I could also look at this pair of angles over here with this pair of angles over here. These two, that's the included side and it's not marked. But this is still marked, the non-included side. These two, the included side is not congruent. That's just telling me parallel. But the non-included side still is. So I could also say the exact same thing. Let's go dot, dot, dot. By angle, angle, side. There's multiple ways I could do this. Sometimes they'll go ahead and throw in this side as well. Like for instance, what if I knew that R was the midpoint of QT? If I knew that R was the midpoint of QT, then I would know that this side and this side are congruent. And now I've actually got side, angle, side as well. Side, side, included angle. Side, side, included angle. But ignore the green because that's not what we have here. I'll go to the drawing, but it will serve the purpose that we have. Okay, so what if I have these two triangles, QRT and SRT, and what if I know that this is a right angle? Well, if this is a right angle over here, then since this is a straight angle or line, I know that this has to be a right angle as well. That's a linear pair. So this has to also be a right angle. All right. What if I also knew that angle Q was congruent to angle S? Now what would I have? Are they congruent triangles? And if so, how do I know? Remember, the only way you can answer the how do I know is 5 reasons. Side, 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 angle, side, angle, side, angle, 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 side, or the one we haven't talked about yet, hypotenuse leg. Now, all right angles are congruent. So automatically these two angles are congruent. So that's an angle pair. That's a congruent pair. These two angles are marked congruent. So I already know that angle Q and angle S are congruent. Is there anything else here? Yes. These two triangles share a side. They share side RT. RT is in both triangles. So I can say that side RT is congruent to side RT by the reflexive property. So I have two pairs of angles and I have a pair of sides. So that makes it either ASA or AAS if we're consistent about which one is, what kind of side it is. Is it an included side or is it not an included side? That's my next question. Well, the included side for, I'm running out of space for my markers here. This angle and this angle would be TS. Is TS marked? No. So it's not the included side over here. The included side for these two angles would be QT. That is also not marked. So this is not an included side. So that means it's a non-included side, which means it's angle, angle, side. And by the way, let me point out, there is no difference between angle, angle, side and side, angle, angle. Same thing. If we turn that around, we're saying the exact same thing. So don't feel like you have to choose between the two. They both mean I have two pairs of angles and I have a pair of sides that is not in between the two angles. So the S is not in between the two A's. Same exact thing. It's a lot like how when we say that there's no ASS, that doesn't mean turn it around and write it like this on your paper, because no, that's the same thing. Okay. So I'm going to say that triangle QRT is congruent to triangle SRT by AAS. All right, now where I want to go with this is let's talk about hypotenuse leg. What kind of triangle has a hypotenuse? A right triangle. So hypotenuse leg is for right triangles. Does that mean I should have used it there? Absolutely not. Do you remember what I said about these two angles? Right angles are always congruent. So anytime you have two right angles, that just counts as a pair of congruent angles. That means you could use right angles with side angle side, you could use it with angle side angle, you could use it with angle angle side. Anytime you have something where you're looking at congruent angles, if they're both right angles, that could be a pair of congruent angles. So that's fine. So what is hypotenuse leg? So first off, we know that hypotenuse leg only works for right triangles because a right triangle is the only kind of triangle that has a hypotenuse. Okay? In a right triangle, the hypotenuse is the side across from the right angle. It's almost like the little right angle symbol points at the hypotenuse. Pointing at the hypotenuse. So my hypotenuse here is this side and this side. All right, so I have a pair of congruent sides that are the hypotenuse. That's part of hypotenuse leg. I also have right angles, also part of hypotenuse leg. So now I got to pick a pair of legs. How about this leg is congruent to this leg? That works. I have a pair of hypotenuses, a pair of legs. It doesn't matter if it doesn't look like it's in the same position. They can be turned around. And I have right angles. Remember how we said we had to have three things for our triangle congruences? I do have three things. Even though this is called hypotenuse leg, and that's only 2 letters, the third thing is that I always have right angles for hypotenuse leg. So I have a pair of congruent angles, and then I also have the hypotenuses that are congruent and the legs that are congruent. So why is this special? Why is this one not called SAS or AAS? You know, what's with that? Why do we have to talk about this one especially? When the last problem we did, that was a right triangle, but we didn't use anything different than we would normally use for that one. We didn't say this is the leg and, you know, leg, angle, angle, or something like that. Here's why. Let's look at what this would be if it weren't a right triangle. What if these were just congruent angles? Pair of sides congruent, pair of sides congruent. The included angle would be right up here. The included angle for this one would be right down here. That's not the included angle. All right, that would mean it can't be SAS because the A is not in between the two S's. So that would have to be ASS, which we're not allowed to use because it only works for right triangles. So that's why we call it HL. So HL is kind of like ASS, which only works if you have right triangles. So you have to make sure that one of the congruent sides is the hypotenuse and one of the congruent sides is a leg. Now, this confuses people. Hypotenuse leg confuses people, and here's why. They want to have it make everything easier so that every time they see a right triangle, boom, it's hypotenuse leg, automatically. That's it. So let's analyze how this works for a second. If the triangle is not a right triangle, then these are my options. Because remember, to be hypotenuse leg, you have to have a hypotenuse. It has to be a right triangle. Remember what I said about the mistake people want to make. They want to say, oh, if the triangle is right, if I see a right angle, then it's HL. But no, if the triangle is right, I still have all those other options plus HL. All that having a right triangle does is expand my options. It does not narrow it down. It doesn't say, oh, okay, it could only be this one. It actually says, now you have 5 choices instead of 4. Because there are 5 congruent or triangle congruence postulates and theorems, but one of them only does work if the triangle is a right triangle, if both triangles are right triangles. So if you see a right triangle, don't look at that as narrowing down your list of options and therefore it's only a hypotenuse leg. No, it could still be any of these others because those 2 right triangles, those 2 right angles are just a congruent pair of angles. So if you see a right triangle, that means you have 5 options that you can decide between. If it's not right, then it doesn't have a hypotenuse, so you really only have 4 options. So let's check this one out. I see that it's a right triangle, both of them are, so that means I have 5 options. Doesn't mean it's HL. Okay, if I want to know if it's HL, one of the things I can do is check the hypotenuse, find the hypotenuse. Remember that the right angle symbol points to the hypotenuse. This is the hypotenuse. In both triangles, this is the hypotenuse. Is it marked? No, but it is congruent because we know that we have a shared side. So this one could be hypotenuse leg because the hypotenuses are congruent. And then there's a leg that's congruent or another leg. Basically, remember that both sides of a right triangle that are not the hypotenuse are called legs. So this could be HL, but what else could it be? This could also be side, 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 because I have 3 pairs of congruent sides. What else could it be? Could also be side angle side. Here's a side, and they meet right here at the angle. Here's a side, they meet right here at the angle. So it is the included angle. The right angle is the included angle both times. So this one, actually, there are 3 options for how I could prove these 2 triangles are congruent. Continuing my not best drawings of the day. What if I have this situation and I have a right triangle here and a right triangle here, or a right angle on both of those places, so they're both right triangles. And what if I have this one marked, and this angle marked? Those are not vertical angles, by the way, but they happen to be congruent anyway. Are these 2 triangles congruent? If so, how do I know? Does hypotenuse leg apply? No, it's not hypotenuse leg. Here's why I know that. This is the hypotenuse of this triangle, and this is the hypotenuse of this triangle. But where would the leg be? I don't have any legs marked. I don't have this leg, this leg, this leg, this leg. None of them are marked. I have not been told anything that tells me that those are congruent. Now, maybe you could tell me this point was a midpoint, and then I would know. But right now, I don't have that information. What do I have? I have 1 pair of angles, another pair of angles, and a pair of sides. 2 A's and an S. So I get to decide if the S is between the 2 A's or not. Is the side the included side between these angles? Here's an angle. Here's an angle. The included side is the one that goes between them. This would be the included angle. The included side, sorry. Included side over here is this one. So that's not the included side. So the S is not in between the 2 A's. So this is what I'm going to use. AAS, or you could say SAA. I hope this has helped. It's longer than I meant for it to be, but hopefully it's complete nonetheless. Thanks so much for watching. Bye-bye.